We'll continue with the z and y parameters. The problem is find z and y parameters for the network shown in the figure. So what I will do is, first I will mark the currents. Current in this branch is I1 plus I2. Current in this branch is I1 plus I2. What current? Assume that there is a source here. The current in the source is I1. The current entering the source also should be I1. Assume that there is a load here. If this current is I2, this current also has to be I2. So that the current in this branch is I1 plus I2. Very, very important. Let us assume this current to be I3. Let us assume this current to be I3. This is node number 2. I will apply KCL, Kirchhoff's current law, at node number 2. At node number 2, we will apply Kirchhoff's current law. What are the currents leaving node number 2? I3 and 2V3. We will add them. I3 plus 2V3 is equal to current entering, which is I2. This implies I3 is equal to I2 minus 2 times V3. I2 minus 2 times V3. Okay. So now what is V3? What is V3? Also what is V3? V3 is equal to 2 times I1 plus I2. That means V3 is equal to 2 times I1 plus 2 times I2. Applying KVL clockwise to input loop gives. This is input loop. What we get? Minus V1 plus 1 into I1. 1 into I1 is the voltage drop across this. My convention, I repeat, voltage rise is treated as negative, voltage drop is treated as positive. Your convention is other way. So whatever equation I write, please multiply that by minus 1, you will get your equation. Minus V1 plus I1 is the voltage drop plus 3I2 plus 2 into I1 plus I2 is equal to 0. This in turn implies I1, what you get? I1 plus 2I1 is what? 3I1 plus 5I2. 3I2 plus 2I2 is 5I2 minus V1 is equal to 0. This I call equation number 1. 3I1 plus 5I2 is equal to V1 or minus V1 equal to 0. Next what we do is we will apply KVL to loop number 2, also called output loop. Applying KVL in the anti-clockwise direction to output loop gives minus V2 plus 2 times I3 plus 2 times I1 plus I2 equal to 0. Substitute what is I3? This implies minus V2 plus 2 times I3. I3 is what? I3 is I2 minus 2 times V3 plus 2I1 plus 2I2 equal to 0. What is V3? V3 is 2 times I1 plus 2 times I2. So substitute that. This implies minus V2 plus 2 times I2 minus 2 into what is V3? V3 is 2 times I1 plus 2 times I2 plus 2 times I1 plus 2 times I2 equal to 0. This implies minus V2 plus 2 times I2 minus 4I1 minus 4I2 plus 2 times I1 plus 2 times I2 equal to 0. This implies minus V2. I2 minus 4I2 is minus 3I2 multiplied by 2. So you get minus 6I2 minus 8I1 plus 2I1 plus 2I2 is equal to 0. So this if you simplify, what you get? You get this implies minus V2 minus 6I1 minus 4I2 is equal to 0. Equation 2. Minus V2 minus 6I1 minus 4I2 is equal to 0. Next step is to find Z parameters. To find Z parameters. Rearrange equations 1 and 2. Rearrange equations 1 and 2 as follows. Keep the dependent variables on the left hand side, independent variables on the right hand side. So for defining Z parameters, V1 and V2 are the dependent variables, I1 and I2 are the independent variables. So we write equation 1 as V1 is equal to 3I1 plus 5I2, and equation 2 we write as V2 is equal to minus 6I1 minus 4I2. Putting the above equations in matrix form. Putting the above equations in matrix form. Putting the above equation in matrix form gives column matrix V1 V2 is equal to 3 5 square matrix 3 5 minus 6 minus 4 multiplied by column matrix I1 I2. This matrix has to be Z matrix. Hence matrix Z is equal to 3 5 minus 6 minus 4. Unit of the matrix is ohms. Next to find Y parameters. Matrix Y is equal to inverse of matrix Z. Using calculator, find the inverse of matrix Z. So you get, this is the answer, minus 2 by 9, minus 2 by 9, minus 5 by 18, 1 by 3, 1 by 6. Unit of the matrix is Siemens. Please check the correctness of these answers. So this problem is slightly complicated because there are three variables here in the circuit, V1, V2, there are three voltage variables, V1, V2, V3, and there are three current variables, I1, I2 and I3. These 6 variables must be reduced to 4 variables. That means we have to eliminate V3 and I3. Okay, this problem is very commonly asked in the examination. Next problem. Next problem. Find Z and Y parameters. Next problem. Find Z and Y parameters for the network shown below. The network is, this is 1 ohm, this is the voltage source, plus minus 3 V2, in series with a resistor of 6 ohms. Then we have a 2 ohm resistor followed by a 4 ohm resistor. This network is given to us. Okay, you have to find Z and Y parameters. What we do is we convert this voltage source into an equivalent current source. So what we get? We get a circuit shown below. 1 ohm resistor. So voltage source becomes a current source. Where the plus sign is there the tip of the arrow must come. Where plus terminal is there, where you have plus terminal, there the tip of the arrow must come for the current source. What is the value of this current source? It is 3V2 divided by 6. That means it is 0.5 V2. It is 0.5 V2. In current 6 ohm resistor is now put in parallel. This is 6 ohm resistor. Rest of the circuit will reproduce as it is. This is 2 ohms. This is 4 ohms. So what we have done is, we have converted this dependent voltage source into an independent current source using the voltage to current source transformation. This is the reference node. Mark all the details. This is node number 1. Potential of node number 1 is V1. This is node number 2. Potential of node number 2 is V2. Once you do source transformation, this problem is fairly simple. KCL, will apply KCL at node number 1. KCL at node number 1. So current in 6 ohms is V1 minus 0 divided by 6. One small mistake I did while writing the problem. There is no unknown here. resistor. Okay. Now we apply case. This is now node number 1. Potential of node number 1 is V1. This is node number 2 whose potential is V2. Now current in this 6 ohm resistor is V1 minus 0 divided by 6. Current in this 2 ohm resistor is V1 minus V2 divided by 2. These two currents are leaving node 1, therefore I have taken them on the left hand side. Currents I1 and 0.5 V2 are entering, therefore I will take those values on those currents on the right hand side. So now we collect terms. This implies V1 by 6 plus V1 by 2 minus V2 by 2 minus 0.5 V2 is equal to 0.5 V2 plus I1. This in turn implies V1 terms if you add, what you get? V1 into 1 by 6 plus 1 by 2 minus V2 by 2 is equal to 0.5 V2 plus I1. 1 by 6 plus 1 by 2, 1 by 6 plus 1 by 2 is how much? 1 by 6 plus 1 by 2, 1 by 6 plus 1 by 2 is 1 by 6 plus 1 by 2. This is 2 plus 2 plus 6 is 8, 8 by 6, 8 by 6. V1 by 6 plus V1 minus V2 divided by 2 is equal to, okay. So 1 by 6, calculate how is that, value it is 1 by 6 plus, so we'll add 1 by 6 and 1 by 12, correct? If you do that, you get how much? This is 12 if you take LCM, 12. This is 2 plus 6, you get 8 by 12. 8 by 12 is 2 by 3. So this is 2 by 3 V1 minus, you take this 0.5 V2 to the other side. So minus 0.5 is 1, minus V2 is equal to I1. This I will call equation 1. So we have applied KCL at node 1. So KCL equation again and cross check. V1 minus 0 by 6 is current in this resistor. Current in this resistor is V1 minus V2 divided by 2. These two currents are leaving, therefore I have taken them on the left hand side. I1 is entering node 1, I have taken it on the right hand side. 0.5 V2 is entering node 1, I have taken it on the right hand side. Now like terms I will add 1 by 6 plus 1 by 2 is 2 by 3. This 0.5 V2 I will take it to left side. So minus V2 by 2 minus V2 by 2 means minus V2 is equal to I1. Next I will apply KCL at node number 2. KCL at node number 2. Current in 4 ohms is V2 minus 0 divided by 4 plus current in 2 ohms is V2 minus V1 divided by 2 is equal to current entering, which is I2. This implies 1 by 4 plus 1 by 2 minus half V1 plus 1 by 2 plus 1 by 4 is 3 by 4. 3 by 4 V2 is equal to I2. This is equation 2. To find Z parameters, I will rearrange equations 1 and 2 so that the dependent variables V1 and V2 are on the left hand side. So we get 2 by 3 V1 minus V2 is equal to I1 and minus half V1 plus 3 by 2 V2 is equal to I2. I put them in matrix form. This implies 2 by 3 minus 1 minus half 3 by 2 multiplied by column matrix V1 V2 is equal to column matrix I1 I2. So this implies column matrix V1 V2 is equal to inverse of the matrix having elements 2 by 3 minus 1 minus half 3 by 2 inverse multiplied by column matrix I1 I2. This is nothing but matrix Z. This implies matrix Z is equal to, please find inverse of this matrix. So inverse of the matrix 2 by 3 minus 1 minus half 3 by 2 inverse. This I leave it to you as homework. Using calculator you find inverse of this matrix. Hence, what is matrix Y? Matrix Y is equal to inverse of matrix Z. Unit of this matrix is Siemens. So using calculator you find inverse of this matrix, that gives you matrix Z. Find inverse of matrix Z, that gives you matrix Y. Like this, Z and Y parameters can be found for this problem. Next problem, find Y and Z parameters once again. The problem is 4 ohms in series with dependent voltage source 0.1 V2. This is the network. This is the reference node. This is node number 2. Potential of node number 2 is V2. This is the problem. Correct? So applying KVL to input loop. Applying KVL to input loop gives minus V1 plus 4I1 minus 0.1 V2 is equal to 0. This I call equation 1. Minus V1 plus 4I1 minus 0.1 V2 is equal to 0. Applying Kirchhoff's current law at node 2. Applying Kirchhoff's current law at node 2 gives current in 10 ohms is V2 minus 0 divided by 10. This current is leaving node number 2. This current 2I1 also is leaving node number 2 plus 2I1 is equal to current entering. On the left hand side I have written the currents that are leaving node number 2, and on the right hand side I have written the current entering node number 2. So this is equation 2. To find Z parameters. To find Z parameters. To find Z parameters. Rearrange equations 1 and 2 so that dependent variables V1 and V2 are on the left hand side. So what we get? Minus V1 minus 0.1 V2 is equal to, or I will take multiply throughout by minus sign. This is V1 plus 0.1 V2 is equal to what we get? 4I1. I have arranged equation 1 so that V1 and V2 terms are on the left side and 4I1 is on the right side. Same thing I have to do here. This is V2 by 10 is equal to minus 2I1 plus I2. Now I will put these equations in matrix form. I will put these equations in matrix form. So what we get? We get 1, 0.1, 0, 0.1, multiplied by column matrix V1 V2 is equal to 4 0 minus 2 1 multiplied by the column matrix I1 I2. This implies column matrix V1 V2 is equal to 1.1 0.1 inverse multiplied by 4 0 minus 2 1 multiplied by the column matrix I1 I2. Now you have to find inverse of this matrix. You have to find inverse of this matrix and multiply by the square matrix has the element 4 0 minus 2 minus 1. The answer is if you multiply these two matrices, the answer is 6 minus 1 minus 20 10 multiplied by column matrix I1 I2. Please check the correctness of these answers. This matrix has to be matrix Z. Hence matrix Z is equal to 6 minus 1 minus 20 10 ohms. What is matrix Y? Matrix Y is inverse of matrix Z. Matrix Y is equal to inverse of matrix Z. Find inverse of matrix Z. So this is nothing but inverse of 6 minus 1 minus 20 10. So inverse of this matrix, do it using calculator. You get 1 by 4, 1 by 4, 1 by 40, 1 by 2, 3 by 20. So many Siemens. I taught you in the class how to find inverse by using adjoint and determinant, also by using calculator. Any one method you can adopt, but using calculator is the best method. Okay. I will go to next parameter. That is H parameters or hybrid parameters. For test, you can expect a similar type of problem. I asked the same problem done in the class with small changes in the numericals. So please go through the problems. Next, H parameters or hybrid parameters. H parameters or hybrid parameters. Let me take again the two-port network. Two-port network. Input port has the voltage V1 and the current into the network is I1. Output port has the terminal voltage V2. Current entering the two-port network is I2. There are four variables V1, I1, V2 and I2. Out of four variables, two variables will make dependent. So V1 and I2 are made dependent variables. V1 and I2 are made dependent variables. I1 and V2 are made independent variables. Two variables are dependent, two variables are independent. Which are dependent? V1 and I2. I1 and V2 are independent variables. So what are the defining equations? Defining equations are V1 is equal to H11 into I1 plus H12 into V2, and I2 is equal to H21 into I1 plus H22 into V2. These are the defining equations. Where H11 is equal to what? H11 is equal to V1 by I1 with V2 is equal to 0. V by I, therefore unit of H11 is ohms. What is H12? H12 is equal to V1 by V2 with I1 is equal to 0. V1 by V2 means H12 is dimensionless. Next, H21. H21 is equal to I2 by I1 with V2 is equal to 0. Since H21 is ratio of two currents, again H21 is dimensionless. And finally, H22 is equal to I2 by V2 with I1 equal to 0. To make I1 0, input port has to be opened. To make V2 0, output port has to be shorted. Correct? Unit of H11 is ohms, H12 and H21 are dimensionless. Unit of H22 is Siemens because H22 is the ratio of current to voltage. Correct? The two-port network is said to be reciprocal. The two-port network is said to be reciprocal if H12 is equal to minus H21. If H12 is equal to minus H21, correct, the two-port network is said to be reciprocal. This is equation 1, this is equation 2. Using equations 1 and 2, we can write the following electrical network. I repeat, using equations 1 and 2, we may write the following network. See, how did we write this? Apply KVL, minus V1 plus H11 into I1 plus H12 into V2 is equal to 0. If you apply KVL to this slope, correct, you get equation number 1. Next, I am going to write the remaining part of the network so that this equation is visualized. Equation 2 is visualized, and that equation is visualized if you apply Kirchhoff's current law at node number 2. If you apply Kirchhoff's current law at node number 2, this is the current source which is H21 into I1, and here I write H22. What is the unit of H22? Unit of H22 is Siemens. That means H22 represents the admittance. This is plus minus V2. This is the current I2. This is node number 2. Apply Kirchhoff's current law at node number 2. Current I2 is entering. Therefore, it is on the left hand side. This current is leaving node number 2. It is on the right side. What is current in H22? It is V2 into H22, not V2 by H22, because H22 is admittance. So if you multiply voltage by admittance, you get the current. So V2 multiplied by H22 gives current in this branch. So and the current is leaving node number 2, therefore I have taken it on the right hand side. In other words, input loop is written, input circuit is written so that equation 1 is realized, and it is being realized by using Kirchhoff's voltage law. This network, which is on the right side, is realized using equation 2 and using the concept of Kirchhoff's current law. Kirchhoff's current law at node 2 gives this equation. KVL applied to input loop gives equation number 1. This is called modeling a network, a two-port network using H parameters. This is nothing but modeling of a two-port network using H parameters. The two-port network is said to be reciprocal. The two-port network is said to be reciprocal if H12 equals minus H21. I told in the class, if you have a network having no dependent sources, it has to be reciprocal. When using Z parameters, if you want to check reciprocity, then what is the condition? Z12 is equal to Z21. If you want to check the reciprocity using Y parameters, what is the equation? Y12 equals Y21. If you want to check reciprocity using H parameters, what is the condition? H12 is equal to minus H21. Now we shall do few representative problems. Find H parameters. Find H parameters for the network shown below. Find H parameters for the network shown below. This is an examination problem. Very simple problem. It's a T network having the elements 2 ohms, 3 ohms and 4 ohms. Current in 4 ohms is I1 plus I2. So which are the dependent variables? Which are the dependent variables? V1 and I2 are dependent variables. Which are the independent variables? V2 and I1 are independent variables. This you must remember. Step number 1. Applying KVL. Applying KVL to input loop. Applying KVL to input loop gives minus V1 plus 2I1 plus 4 times I1 plus I2 is equal to 0. This implies minus V1 plus 6I1 plus 4I2 is equal to 0. This I call equation 1. Applying KVL to output loop we get minus V2 plus 3 times I2 plus 4 times I1 plus I2 equal to 0. This implies minus V2 plus 4I1 plus 7I2 plus 7I2 equal to 0. Equation 2. To find Y parameters, what we have to do? We have to write two equations. In those equations, V1 and I2 terms must be on the left hand side and V2 and I1 terms must be on the right hand side. Rearrange equations 1 and 2 as follows. Rearrange equations 1 and 2 as follows. Minus V1 plus 4I2 is equal to minus 6. Next equation, 4i1. So next equation, I2 term should be on the left side. 7i2 is equal to minus 4i1 plus v2. Again repeat, dependent variables namely v1 and I2 should be on the left hand side. Independent variables must be on the right hand side. This is minus 6i1 minus v1 plus 4i2 is equal to minus 6i1. This equation becomes what? 7i2 is equal to minus 4i1 plus v2. Putting the above equations in matrix form. Gives minus 1 4 0 7 multiplied by column matrix v1 I2 is equal to minus 6 0 minus 4 1 multiplied by column matrix I1 v2. This implies column matrix v1 I2 is equal to minus 1 4 0 7 inverse multiplied by minus 6 0 minus 4 1 multiplied by column matrix I1 v2. You take inverse of this matrix and multiply, you get the result 26 by 7 4 by 7 minus 1 by 7 minus 4 by 7 and 1 by 7 multiplied by column matrix I1 v2. This is H matrix. All elements of H matrix do not have the same unit. This is H11. What is H11? H11 is 26 by 7 ohms. What is H12? Dimensionless. It is 4 by 7. What is H21? Minus 4 by 7. Dimensionless. And finally, what is H22? It is 1 by 7. Unit is Siemens. Since H12 is equal to minus H21, it implies two-port network. Two-port network is reciprocal in nature. Two-port network is reciprocal in nature. So this is how the problem has to be tackled. We shall do one more problem. Find H parameters for the two-port network shown in the figure below. This is the problem. Normally in the examination, The problem will contain dependent sources. This I take as a reference node, whose potential is 0. This is node 1, potential of node 1 is V1. This is node 2, potential of node 2 is V2. We have to get two equations containing the variables V1, I1, V2, I2. Then dependent variables must be thrown on the left side and independent variables should be thrown onto the right side. V1 and I2 are dependent variables. V2 and I1 are independent variables as far as the computation of H parameters is concerned. Now what is I0? What is I0 in this equation? What is I0? I0 is V1 minus 0 divided by 1. That means I1 is nothing but V1. So the two equilibrium equations can be based totally on KVL or totally on KCL, or they could be one equation KVL, one equation KCL. It depends upon the topology of the two-port network. Please note that two-port network should not contain independent sources. Not allowed. Okay? KCL, let us apply KCL at node 1. Let us apply KCL at node 1. What is current in 1 ohm? Current in 1 ohm is V1 minus 0 divided by 1. What is current in 9 ohms? It is V1 minus V2 divided by 9. Correct? These are the two currents leaving node 1. This must be equal to current entering, which is I1. So this is V1. If you take V1 common, you get 1 plus 1 by 9 minus 1 by 9 V2 is equal to I1. This implies 10 by 9 V1 minus 1 by 9 V2 is equal to I1. This is equation 1. Kirchhoff's current law at node number 2. Kirchhoff's current law at node number 2. Current in 9 ohms is what? V2 minus V1 divided by 9. This current is leaving node number 2 plus 5I0. 5I0 is also leaving node number 2 is equal to current entering, which is I2. But what is I0? I0 is nothing but V1. So this implies V2 by 9 minus V1 by 9 plus 5V1 is equal to I2. This implies, if you take V1 common, you get 5 minus 1 by 9 plus 1 by 9 V2 is equal to I2. This in turn implies 45 minus 1 is 44. 44 by 9 V1 plus 1 by 9 V2 is equal to I2. Equation 2. Rearrange equations 1 and 2. Rearrange equations 1 and 2 as follows. Independent variables must be on the right hand side, dependent variables must be on the left hand side. In this equation, V1 is dependent variable. Correct? So keep it on the left side. So you get what? 10 by 9 V1 is equal to I1 plus 1 by 9 V2. This is how equation 1 is rearranged. And please note that the variable with suffix 1 must be the first term on the right hand side. Next, in this equation, V1 is dependent variable, I2 is dependent variables. They must be on the left side. So what we get? 44 by 9 V1 minus I2 is equal to minus 1 by 9 V2. Next is putting the above equations in matrix form. Putting the above equations in matrix form. Putting the above equations in matrix form gives So 10 by 9, 0, 44 by 9 minus 1 multiplied by column matrix V1 I2 is equal to square matrix 1, 1 by 9, 0, minus 1 by 9 multiplied by column matrix I1 V2. This implies column matrix V1 I2 is equal to inverse of the matrix having elements 10 by 9 0, 44 by 9 minus 1 inverse multiplied by 1, 1 by 9, 0, minus 1 by 9 multiplied by column matrix I1 V2. Using calculator, find the inverse of this matrix and multiply by this square matrix. The result I will write 9 by 10 is the first element. Next element is 1 by 10. Then we have 22 by 5 and 3 by 5. These are the four elements multiplied by the column matrix I1 V2. Therefore H11 is equal to 9 by 10 ohms. H12 is dimensionless 1 by 10. H21 is equal to 22 by 5 and H22 is equal to 3 by 5 Siemens. Please note that H12 not equal to minus H21. Therefore, the two-port network is not reciprocal. In the previous problem, the two-port network was reciprocal. Here it is not reciprocal.